In today's lecture, we are going to see about the work energy method. We know that work done is equal to force into distance moved. Consider a body of mass m here. It is moved by a distance of s meter by a force p here. So the work done by the force is equal to force into distance moved. So the applied force is p and the distance moved by this body is s distance. So we can give the relation as the product of force, that is p into distance, which will give you the work done by the force here. Consider this same example by which this applied force P is acting at an angle theta here. Whenever the force is acting at an angle theta here, this P force can be resolved into two component of force, one along the horizontal direction and another one along the vertical direction. So here with this body, it will be moved in the x direction at a distance of x here. So here this P into cos theta is the component of force which actually causes the body to move towards right side direction, that is in this figure, at a distance of s here. So the work done can be given as the component of force in direction of motion, since the work done is given by the component of force in direction of motion is p into cos theta and the distance moved is s here. So p into cos theta into s will be the formula for finding out the work done whenever an inclined force of p is acting on the body here. So here there are some four conditions by which this work done can be applicable. In this equation, if s equal to 0, that is when a distance is equal to 0 here, then work done will be also 0 here. When you put s equal to 0, work done will be 0 here. Take the second condition, if theta equal to 90 degree. If you put this theta equal to 90 degree, cos 90 equal to 0 here. So the work done will be also becomes 0 here. Take the third condition, if the body moves in the same direction of the force, then work done will be considered as positive. If the body is moving in the right side direction and the applied force is also acting in the right side direction, then the work done is said to be positive here. And the fourth condition is, if the body moves in the opposite direction of force, then work done will be said to be as negative here. With this, we shall see about this work energy principle. The work energy principle is given by this equation, work done equal to change in kinetic energy. Change in kinetic energy is nothing but final kinetic energy minus initial kinetic energy. Consider a body by which some 3 or 4 forces are acting, F1, F2, F3. All are acting on this body and makes this body to move in this x-axis at a distance x here. The net force acting along this x-axis is given by the summation of all these forces which are acting in this x direction, that is summation fx. Therefore, work done by the body, we know the formula force into distance, that is force here is summation fx into distance, that is s distance. And in the right hand side, the change in kinetic energy is given by the formula half into mv square minus half into mu square. So we know that W equal to mg. From this, m equal to W by g here. If you substitute instead of this m, W by g, we can get the equation as half into W by g into v square minus u square. So the work energy equation is given by work done equal to change in kinetic energy, which is the final formula we have arrived, that is summation fx into s is equal to w by 2g into v square minus u square.